Hello, geometry friends. More dilations today. Today is the second video about dilations. The first one told you how to do dilations on a coordinate plane. And in a nutshell, we said when you dilate something from the origin on a coordinate plane, you multiply the coordinates by the scale factor. Well, if you want to dilate something other than a point on the coordinate plane, like a line or a segment, you do much the same thing, but how that affects the equation is what we're going to figure out today. So, if I want to dilate a linear equation, it says dilate A and B by scale factor 2, centered at the origin, and plot the new points. So let's go through this exercise and see what happens. Well, point A is the point 0, 3. And so if I dilate that by 2, 0, 3 multiplied by 2, is 0, 6. So there's A prime. And B is the point 4, 1. Dilated by 2 would become 8, 2. I'm multiplying the coordinates, so there's B prime. And here's my new line. Cool. Then it says write the equation of AB. All right, fine. Well, AB has a slope of down 1, right 2. So my slope is negative 1/2. And my y-intercept is 3. So it's going to be y equals negative 1/2 x plus 3. Write the equation of AB, or pardon me, A prime, B prime. I keep saying the wrong thing. I'll get better. So to get from A prime to B prime, I'm again going down 1, right 2. That's also because of what we talked about in the last video where we said dilated segments are parallel to their originals. So my slope is still negative 1/2, but now my y-intercept is 6. So y equals negative 1/2 x plus 6. What stays the same and what changes? Well, what stays the same? My slope stays the same, okay? Because those lines have to be parallel. And what changes? The y-intercept changes. And in fact, my y-intercept was 3. It became 6. I dilated by 2. And in this case, my y-intercept is multiplied by the scale factor. Now, the reason that happens right now is because we are dilating from the origin. Remember, when you don't dilate from the origin, you can't bank on that just multiply by the scale factor idea. And, I mean, that's it. So if I were going to explain this page in a nutshell, it was when you dilate a line, it's parallel to the original, so it keeps the same slope, and your scale factor gets multiplied by your y-intercept. So the line y equals 3x plus 7 is dilated by a scale factor of 3. What's the new equation? The slope stays the same when you dilate, so it's still 3x, but the y-intercept gets dilated by the scale factor. 7 times 3 is 21. That's it. Don't make it harder. Anaya sees two lines with equations of y equals 1/2 x plus 8 and y plus 2 equals 3/4 x minus 7. Explain how you know that the second line is not a dilation of the first. Well, we just said when we dilate something, the slope should stay the same. My original slope was 1/2. This line right here is in point slope form. To remind you, that's y minus y1 equals mx minus x1. So my slope is right here. 1/2 and 3/4 are not the same. So this can't be a dilation because the slope changed. Okay? So new changed slope. Therefore, 3 dots like that is therefore not a dilation because the dilation slopes should stay the same. Find the new equation of the line y minus 2 equals 3 times x plus 1 after a dilation from the origin with a scale factor of 3. Well, remember how I said when you dilate a line from the origin, you multiply the coordinates by the scale factor? This line is in point slope form. So this line has a slope of 3 and contains the point negative 1, 2. Because of how point slope form works, you negate the point. If I dilate that by a scale factor of 3, my new slope isn't going to be new at all. It's just going to be 3. The slope stays the same. But my new point is going to be negative 3, 6. So if I want to find the new equation of the line, y minus y1 equals mx minus x1. Negate the point, put it back. If you dilate from the origin, you multiply your points by the scale factor. If you notice, I could have done that right off the bat right here and said a scale factor of 3 times 2 is 6. 3 times 1 is 3. Multiply the point by the scale factor, the slope stays the same. The line represented by negative 3y plus x equals negative 9 is dilated by a scale factor of k centered at the origin. The image of the line has equation of y equals negative 1/3 x equals 6. Find k. Whoa. The only forms of a line that you should really enjoy working with are point slope form or slope intercept form. Y equals mx plus b or y minus y1 equals mx minus x1. Anything else, for most uses, kind of garbage. So if I have a line that's written like this, I do not want to leave it that way. I need to get that in y equals form. So if I have negative 3y plus x equals negative 9, I'm going to subtract x. So I have negative 3y equals negative 9 minus x. Divide everybody by negative 3. So I get y equals positive 3 plus 1/3 x, because negative x divided by negative 3 is 3 plus 1/3 x. Okay, so that one's in y equals form. Now I'm going to take this other one right here and get this thing in y equals form, which is faster. Yay. Okay, so this was equation number 1. This was equation number 2. They say they were dilated. I can believe that because the slope stayed the same. And what was it dilated by? Well, my y-intercept of 3 became a y-intercept of 6. So our scale factor k, we multiply by 2. At the end of the day, though, however many minutes I've been talking right now, you just need to know that when you dilate something from the origin, slope stays, y-intercept gets multiplied by the scale factor. That's what happens. All right. What do we got on the back? The line y equals 3x was dilated by a scale factor of 2 centered at the origin. Write the equation that represents the image after dilation. Wait a second. If I'm going to dilate that by a scale factor of 2 centered at the origin, y equals 3x is y equals 3x plus 0, right? Because my y-intercept is 0. If I dilate that by a scale factor of 2, my slope is going to stay the same. My y-intercept is going to be multiplied by 2 and stay the same. So y equals 3x plus 0, or really just y equals 3x, is the new line. But it was also the old line. What happened? It stayed the same. Why did it happen? Well, it happened because if you dilate a line from a point on the line, its equation doesn't change. We dilated y equals 3x centered at the origin. Y equals 3x contains the origin. So if you dilate a line from a point on the line, it doesn't do anything. Nothing happens. Okay? The line y equals negative 2x plus 4 is dilated from the point 2, 1 by a scale factor of 3. Write the equation that represents the image of the line after the dilation. All right, so negative 2x plus 4. So here's 4. My slope is negative 2, so down 2, right 1. Whoop. So I have y equals negative 2x plus 4. And we are supposed to dilate this not from the origin, but from the point 2, 1. 2, 1 is right there by a scale factor of 3. Okay, so if I want that to work out, we need to go back to what happens when you dilate something from a point that's not the origin and from a point that's not on the line. Well, what happens is you push it further away. So if I'm going to dilate this by a scale factor of 3, from this blue dot, let me try to zoom in here, from this blue dot to this point right here that I'm kind of dotting blue, that's 1 down. If I multiply that by a scale factor of 3, it's now 3 down. 1, 2, 3. There's the new point. If I look at the distance from this blue dot center to this point right here, I go up 1, left 1. Dilate by 3 is up 3, left 3. That is my new line. Now, what is the equation of that line? Let's see. The slope should still be the same. So I would go up 2, left 1, up 2, left 1. Now my new y-intercept is 2. So it would be y equals negative 2x plus 2. What happens if you dilate that line using a scale factor of 1? Guess what? Nothing. If you ever use a scale factor of 1, nothing changes. It means, hey, show that thing itself in the mirror and let it wave. That's all that happens. So when you dilate by a scale factor of 1, nothing happens. All right, lesson summary. Let's wrap this up and turn this video off here. When you dilate a linear equation, the slope stays the same. When dilating a linear equation, the points or y-intercepts are multiplied by the scale factor if the origin is the center of dilation. So your points or your y-intercepts also get multiplied by a scale factor, assuming that your origin is the center of dilation. Otherwise, you would count it out to figure out your new points or new y-intercepts. And if the center of dilation is on the line, then the line doesn't change. Ta-da! That's it. So I am done. I hope that this made some sense. And if it didn't, reach out to me. I hope you're having a great day. Continue to have a great day. And, do something cool. See you later.